In this video from Chapter 10, we're going to go over some of the calculations in bonds. So from the textbook, this is one of the spreadsheets from the textbook. And what we have here is the settlement date, maturity date, annual coupon rate, which I usually like to express as a percentage. Yield to maturity, again, should be expressed as a percentage. Redemption, the face value is 100%, and coupon payments is twice a year. So that means it's what we'd say semi-annual. Okay. Now, to calculate the price, what the price of the bond should be as a percentage of par, we could use the price function. So as displayed over here, so if I'm going to delete this cell, and I'm going to go to functions, insert function, and look up price. Okay, so then we have the price here. First thing I want to put in is the settlement, then the maturity, then the rate, then the yield, then the redemption, and then the frequency. So we're done. Now we get the percentage of par. So coupon, you can use the formula coupon day BS. So you see the formula here, and you can use that search function again to get the formula, and you just fill in the settlement, maturity, frequency, and basis, which is 1. So I'm going to show you the days since last coupon, and then the days in coupon period. If you do the same thing, a new formula, coupon days, put in the settlement, maturity, frequency, and basis, you get the days in the period. Accrued interest. So with accrued interest, we're going to be using just that straight formula, which was the days, and this is from the textbook, this formula, the days since the last coupon divided by the days in the coupon period, multiplied by the annual coupon rate times 100 divided by 2. And this should be expressed as a percent. Invoice price, again, for this, we're just going to add the flat rate plus the accrued interest. Okay. Now you can see here that these are just 3 other examples. We're talking about a 3.75% bond and a 8% bond. So these are just 2 other examples you can scroll through that will give you the same results. Okay, if we look at, this is the second spreadsheet as listed in the textbook. Let's clean this up a bit. Okay. So again here, we're using yield to calculate the yield to maturity in this example. So if we, formulas, insert function, we'll see that the yield formula comes up. And in here, settlement, maturity, rate, this would be the bond price, PR for price, redemption, and then coupon payment frequency. No basis needed. Okay, so I will show you how that's calculated. Search for yield. Okay, so for settlement, maturity, coupon rate, bond price, redemption value, frequency. and then we get the yield to maturity. So that's for semi-annual coupons. Now for annual coupons, it's just going to be the same inputs, but the frequency goes to 1. And you can see how these are the same inputs, but now the actual rate is slightly different because of the compound interest. Okay, so let's just go over some bond valuation basics. So if you want to calculate bond value and you're not dealing necessarily with dates, you can use the present value function. So if we go into, let's drift it up a bit, our formulas, and we pull in present value, and we enter in the rate. This is the coupon rate, N per, which is the number of periods. Actually, let me start over this. The rate should be the required rate of return. N per is the number of periods, which is, this is an annual bond, so it'd be 10 periods. So number of years is 10, but it's also, frequency will be 1. Payment be the annual payment on the bond. Future value will be the par value. And just hit done. Now, with present value, so it's going to express it as a negative number. So you can fix that by multiplying by -1 if you don't want to see a negative, because it really is not a negative bond. There's no negative bond values. Now, let's do it again for what if the interest rates, the required rate was lower than the coupon rate. So this would be, we'll see this let me just fill this out first. So you see that this will trade at a premium because your bond is paying a higher rate than the required current rate. And if I just drag this over, we'll see that a required rate of 7% pays an even bigger premium. So try the 3 bonds here. Example. This is example now of required rates going up. So I'll give you a second, pause the video, and try to complete these. Okay, so these are the answers you should have received for these 3 answers. Okay, moving down, another way to calculate yield to maturity is we could use the internal rate of return function. So with this function, we just need to highlight the values and hit done. And this will calculate the yield to maturity using the cash. It's basically using time value money to discount all of the cash flows. So try the second problem here on your own. So pause the video and try the second problem. Okay, so you got 12.5%. Now another way to calculate yield to maturity. Now this is the same inputs here as this problem here. Cash flow. So if we go down, we're basically using the same inputs here. So we want to calculate the yield to maturity. Here we could use the rate function. So this is another function we could use to calculate yield to maturity if we as a different way of doing it. So N per is 10. Payment 100, and the payment is the bond times the coupon rate gives the annual payment. Present value is the bond's current value, and future value is the par value to be paid in the future. And you see here how we get the same answer using this layout. So it's just a 2 alternate way. So calculate this two remaining problems here for you to try to pause the video and calculate on your own. All right. I'm just taking a shortcut and cutting and pasting, but if you fill out the rate, you'll see that if you click on the cell, you should have these boxes filled out with these answers. Now, what if it's a semi-annual bond? And most bonds are semi-annual. So when you're going to calculate this, and you want to calculate the current value, the present value of the bond. Okay. Okay, so to do this, we're going to use present value again. Okay, so for the rate, we would take the required rate, but we're going to divide by the frequency. And for n per, we're going to take the number of years to maturity, and we're going to multiply by the frequency. And for we have the payment, so here's the interest payment. So the interest payment, you could calculate the interest payment by par value times coupon rate divided by 2. So we're just going to, I already calculated it here, so I'm just going to put the 50 in there. The future value is the par value. So if we calculate this, and you're going to have to again multiply by -1, and this is the current value of the bond. So try that on these two examples here by yourself. Pause the video, try it. When you come back, I'll have the answers posted. Okay, so this would be, and if you, I'm just double checking everything. So yeah, so these would be the remaining answers for the value, current value of the bond based on these inputs for semi-annual bond. Okay, so that's simple enough. So the last example is sort of a problem. It's just going to talk about a corporation that has bond issue in 2015 at 6% rate. So this would be the to-do list. So I've already kind of took the information in the problem and I separated in the to-do list. I've written out for the different A through D. And we want to calculate the yield to maturity. I already have a formula here for the annual yield. This is multiplied by 2. So the yield to maturity rate. So in this, you would want to use, again, the rate function to calculate the rate here. So this is yield to maturity semi-annual interest. So we have our coupon, par value, our payment, number of years to maturity, number of periods to maturity, and the current bond price. So if we want to find the rate, again, we're going to use the rate function. So the hint is here. Put these hints in parentheses. So n per is here because it's 15 years, but since it's semi-annual, it's multiplied by 2. So I just have the full frequency here. Payment, 6% times 1,060, but since it's semi-annual, twice a year, the payment's 30. Present value, they give us the present value here, and it already has a negative, so that's going to help. That'll give us a positive value in the end, and the future value is 1,000. So then this would be the, let me just shrink this a bit. This would be the yield to maturity rate, semi-annual, and this would be the annual rate, because just multiplying by 2. So the bond value, if we want to calculate the bond value, we could use present value, just like we saw in the previous problems here. Now I'm just putting them in a little bit more organized problem. Again, we'd want to take the rate, the n per, payment, and so basically I use the spreadsheet to divide by 2 here and multiply by 2 here to get the, instead of doing it in the formula, but either way is fine. Okay, so this would be the current bond price, and again I would have to multiply by -1 to get to be a full price. And you can see as if the rate is higher than the coupon, it's going to be selling at a discount. The required rate is higher than the coupon. Okay, so a bond semi-annual interest. So here again we're calculating the bond price using present value. So we have, this is semi-annual. So we want to calculate the rate. and per payment future value. So this is the yield to maturity. So the yield to maturity rate, we're assuming it's semi-annual, the rate they're giving us, but they're not specifically saying. But usually the yield to maturity rate is going to be the semi-annual rate. So if they gave us the annual rate here, if this was an annual rate, we'd have to divide that by 2. But since this is yield to maturity, we're using that as considering this is a 6 month rate. Okay, so that's just a further problem to kind of utilize the what you've learned in the previous calculations. Okay, so this has been the video to help explain how to calculate values of bonds using various Excel functionality. I hope you found it helpful. Thank you for your time. I'll see you next chapter.